Hey, what's up, guys? So today I want to go over something very simple, and that is to teach you C++ in about 10 minutes. Can we do it? Let's get started. Well, the first thing I want to do, I have Visual Studio Code here. Let's open up a file. Let's actually create a file, and let's just call it program CPP. With With C++, you typically have header files and you have source files. Your source files are CPP files. So let's start off with something really fast. And with C++, you have to include any libraries that you want to use. And one of the most common ones is, and my mind went just went blank right there. IOStream, I believe that's it. Using namespace std. And one thing about using namespace std, and I'll show you what it does. Basically, a lot of things are in namespaces in C++. And when you have a namespace, by doing this declaration, you don't have to specify the namespace for everything. So the first thing, the entry point for any C++ class is that you must have a main. So in order to have a main, you declare it, it returns an int, it's called main, and then it has a couple of parameters. These are can be called parameters or arguments, and I forget which is which. When you declare it is arguments, when you call it is when you declare it as parameters, I believe, and then when you call it, they're arguments. So let's just say argc and argv, and just an array. And don't worry so much about what an array is at this point, or any of this stuff is. I'm going to cover it in detail. So the first thing you need to know is that this is a function. A function in C++ has the characteristics of a return type or no return type. And in that case, it has to be void. We'll go over that in a second. But let's do something really simple. And the main has, of course, a body. You notice that I put a curly brace here and a curly brace down here. And curly braces are used for scope. So everything within that scope is for it's how C++ knows where its boundaries of whatever that thing is begin. In this case, it's a function. So the boundaries are that opening curly brace and that closing curly brace. And the first thing you want to do is say hello world. And we'll just say hello world. And endo. And this is just to make sure that everything runs. And so let's go ahead and save it. And one thing I want to do is I want to move this down a little bit, because what I want to do is I want to view the terminal on Visual Studio Code. And oh, I didn't count on this terminal not showing me what I was typing. So let me see if it'll let me see. Okay, see, it does. It will go over to the next line. So what I want to type first is the command to run C++, and I just want to compile my CPP program, and I want to name it p1.exe. And normally in Mac you don't have exes, but I like to call them exes anyway to tell them apart from other files. So that should compile my program, and that does compile it. Now to run the program, I have to do ./p1.exe, and you notice it outputs hello world right there. And let me close this for now. Yeah, that's what I want to do. So just real quick here. So one thing about it is you notice that I have the on line 1 include IOStream, and that's because I want certain functionality coming out of there, like this cout, in order to print to the console. And then that's really all I need from it in order to do that. Otherwise, without it, it would have problems if I didn't have that. So let me show you an example like this. The double slashes, those are comments. That means that anything that's in a comment is more of documentation for another developer to be able to look at the code and know that, hey, this is an instruction for the reader, not so much for the computer itself. But you notice at this point, if I try to save it like this, and then I try to, matter of fact, you already see the red squigglies. It says, see how it is undefined. And that's because I'm not including the library. So once I include IOStream, it does that. It'll do the same thing with the cout statement. If I don't have using namespace std and I save it, you'll notice that it has a problem. And if I don't use std, that means I would have to do this every time. Think of it kind of like when you have like a city, okay, you could have Selma, Alabama, Selma, California. Which Selma are we talking about? But it's kind of backwards, right? So you say Alabama, Selma, and then what country? Because there could be other countries with those states, right? But it probably isn't. There probably aren't any, but you get the point. So I would have to do that. But when I say that I'm using the namespace because they're in the namespace std, and all the namespace is like a wrapper for whatever you write. For example, you would say something like namespace something, and then you would wrap whatever definitions you have inside that namespace. That means that in order to use a class out of there, since remember, these are boundaries, so that's the scope within that. But that, in order for me to identify it, I'd have to say using namespace something in order for me not to do it. Like if I define a function called foo, and actually you wouldn't define it that way, it'd be more like void foo. Then in order for it to see it, if I wanted to use foo, I couldn't just say foo. It would not recognize it. And I go ahead and save it. Notice foo's not recognized. But if I say something foo and I save it, now it recognizes. And that's all a namespace is. That's all it is. Now, why do you want namespaces? Well, if you write a lot of code and you have a lot of libraries and you reuse a lot of code, you want to have stuff namespace. All the programming languages do it. And that's just so you can separate, for example, a good namespace for your product might be the company name. For example, for Google, their namespaces might be Google, and then maybe they have namespaces for utilities. So it might be Google.utilities or something like that. That way they don't cross match. So if somebody else defines foo, well, we know which foo we're talking about when we give it the full namespace, right? Just like in the case of where we have states like Selma. Well, are we talking about Selma, Alabama, or Selma, California, or Selma, Texas? So we have to know that. So that's all the namespace is. Okay, and I thought I'd just point that out. Anyway, moving on with that. So we don't need to do that, and we don't need to do this. So we have our hello world. Well, with any computer programs, there are a few things that you need. You need to have usually it's input, processing, and output. Okay, and input can come in the form from a file or from the console or whatever the case may be, but the computer needs to have a way to store that into memory. That's where variables come in. But in order to declare variables, we have to know their types. And C++ is static. It's a static language and it's strongly typed, and therefore you need to know the type. So C++ has many types. There are many types, but the main ones you have to know, there are a few, is int, or if I say int a, and I say equals 0, and I can say float, and I'll call it f, equals 0.0, and then I may say char, and I could say c, or ch equals a, or I may say char, where I have an array, and then I can say equals, and then I could have a whole list of characters. And you notice how I have to separate them. So I'm initializing here, I'm initializing an array with 3 different values in it. And we'll get more into that, but for now, just don't worry too much about it. The int, of course, this is a number, and because I'm assigning 0. And so anytime I need to use a number, I can use int, except that this is only for whole numbers. So it's like 0, 1, 2, 3, 4, 5, or even negative numbers. There are other types in there. Like I said, there are many types in C++. There's unsigned numbers, where you might have a uint or something, and that can only be 0 through whatever, only positive numbers, no negatives. But int can go negative. They have the negative min and the negative max. They don't hold any number. It's not infinite. They have maximum limits. There's double. There's also another number, float. Double. And this has to deal with the position of the number. For example, how many digits out, how far can it go and still maintain its integrity? And the float, of course, is like one length, and then the double has a higher length of position. It also can use more space, so it can actually give bigger numbers. There's also, for example, long, if you needed even a bigger number. And you may be wondering, well, why do I need to have a long and an int? They're both whole numbers. Int and a long, they're both integer numbers. But one has actually a bigger size. So for example, you know that everything in computer comes down to bits and bytes. In C++, an int is 32-bit integer, while a long is a 32-bit integer. A 64-bit integer. So it can hold not double the size, it can hold double the size in bits, but that's a much, much bigger number, okay? So it's a much, much bigger number. So if you really needed to have like a really higher number, then whatever that long is, I don't know it off the top of my head. You can look it up. Look up what's the maximum number you can store in a unsigned, an actual signed long or signed 64-bit number or signed 32-bit number. Okay, don't worry too much about that. What you do need to worry about is sometimes you're going to need whole numbers. Sometimes you're going to need floating point numbers, like in the cases when you're dealing with money, when you're dealing with averages, stuff like that. Sometimes you're going to need strings, but strings are composed in, and this comes from C, they're composed in arrays of characters. So like this one can hold A, but it can't hold, like, for example, AB. That's not valid, okay? But CH can hold multiple, but then it's kind of like, okay, well, that's not. But then there's something called a C string, which is something like this. And actually you can say CH equals, and then you could say something. I believe you can do this, okay? And that's a string, and it'll actually output the string. So let's see, let's output all this information just to kind of give you an idea. Okay, so just to kind of give you an idea on all of this, let's go ahead and output all of this. Okay, so we're gonna do cout A, and we'll say, and we're gonna do the same thing for B, F, D, and all of those. So we could just take and copy all of this. Oh, I don't like the way it did that. It was supposed to give me a whole new line, but that's not the way it worked. So that's the other thing, it didn't do my tabbing correctly. My indentation. So let's see, we got A, we have B, we have F, we have D, and we have a few more. Okay. So we have D and F, and let's say we got CH, and then we have CH array, and then we have, oh, we can't have the same name. That's another thing about variables. You can't have the same name. Well, think about it. Like if you have two people named with the same name in the same place, then how do you refer to each one? Then that's when it gets into last names. Well, variables don't have last names. They just have single names, but They have to be different. So in this case, we'll call one CH1 and CH2. And so here we'll say CH1, and we'll call the other one CH2. And we'll see what they hold in them. And then we'll see, like, for example, in this case of CH1, we'll put CH1, see if it even does something. It might spit out a whole bunch of garbage. And I'm going to tell you why in a second. You'll see why does one work and one doesn't work, and we'll see how to fix it. Well, let's go ahead and take that. So we have all those, we save it, and let's go ahead and run it. Actually, let's compile it because it has to compile. And then let's run it. And you notice I got everything there. And you notice the CH1 has some weird junk in it. And it's like A, B, C, A, Y, but there's no A there. Well, the reason for it is because in reality, a C string has a null terminating character. And remember when I said earlier that you could put 2 characters in there and you could only put 1. But now I'm violating those rules. I'm putting 2 characters, slash and a 0. Well, even though this technically is 2 characters, the way the computer sees it is as 1 character. It's a /0. It's an escape, what's called an escape sequence. And so this null terminating character basically tells the string where to stop. So for example, if I was to add a character even after this, like Z, and then I go ahead and run this again, go ahead and compile it and run it. And you notice that CH1, even though it has ABC /0 and Z, it stops at ABC. And that is because of this. That's because once the rules of C strings are that once it sees this, even though there's more, and I can access that more, and I can show you how I can access it. If I was to say C out, and I say CH1, and arrays, one thing about arrays is they're 0 base. So this is CH1 0, CH1 1, CH1 2, CH1 3, and CH1 4. So 0, 1, 2, 3, 4. So if I was to access CH1 4, which I would access it just like this, you'll see that it will actually output a Z. So if I run it, if I save this, let's compile it real quick, and let's run it. You notice that it did give me the Z. So it knows it's there and it's in memory, but the cout statement says, hey, when I see a /0, I stop printing. I stop. That's the end of that exercise. And that's exactly what it does in that case when it sees CH1. So you can have, we talked about different types, and you may wonder about this array. It's like, okay, what is this array? Why does it have the brackets? Well, an array, think of it like it's a way to define something as one single type. Let's say, for example, that you had an array, and one thing I didn't get into, but C++ also has this, but this is a full object, and it's called a string. And I can have, for example, name, Joe, and C++ understands that. And in order for me to use the string, though, since it's an object, it's not just part of C++, it's part of the libraries in C++, and I have to include the string library. And so I'm doing this all wrong here. This is not supposed to say endo. It's supposed to just assign Joe to it, and then output endo down here. Output name. And then it outputs it. And so there, I can output the name. And you notice it'll output Joe down here at the bottom. So that outputs Joe. But what if I had like a whole list of names or something like that? So I want a whole list of names equals, and I can say, let's say I have 10 names. And that's enough for me to store 10 names. Now I can say names 0 equals Joe. Names 1 assign, and when I say equals, I'm not really saying equals, it's just the equal sign, but I'm assigning the value. It's not like your math equals, okay? So I'm assigning the value. So whatever's on the right is getting assigned to the variable on the left. I couldn't do it the other way. I couldn't say like Joe equals names because that doesn't even make any sense. For example, I couldn't say John equals, because it's not an equality comparison. And this is going to give me an error. It's going to say, what are you doing? Okay. It doesn't know. It's like, oh, this doesn't work because I'm trying to assign a value to a string literal, and that's not possible. I can't overwrite this. I need a variable on the left-hand side to store it because this is a place in memory. It takes up memory, but it doesn't have a variable, so I can't assign anything to it. Okay. So now, how do I display names? Well, I can't, one of the things about arrays, I can't just say names like this. It'll probably output the first name. I don't know, it might, because the place of memory, or it might just say, hey, I don't know how to deal with arrays. Right, so let's go ahead and try to run it and see what it does. And you notice it does something weird. It's like, it did Joe with the name, and then it did this. Well, this is a hex value, and it's really a place in memory. That's all it is. It's a place in memory, and so it can't tell you. So if I want to display names, I would have to actually tell it which name I want to display. If I want to display name 0, if I want to display name 2. So, or, named 1. And the array, notice it's fixed at 10. If I assign, I can assign all the way from 0 to 9, but if I assign into the array names 10, which is out of the bounds of the array, and let's say I try to assign that, and then I try to actually read that, I may get an error depending on the compiler, or I may not, but I'm not really allowed to access that. So if I compile this program, then it tells me, hey, look, okay, array bounds, array 10, index 10 is passed. So it can't do that. And you can't do negatives either. So it's names 10, it's like, you can't do it. That doesn't mean just because cout does it, that doesn't mean that someone else can't do it. Like if you try to access it for some reason, notice that it didn't blow up here though. It blew up down here in the cout. Cout was smart enough to know, but my assignment didn't. So what's up with that? C++ is like that. You look, it gives you all the rope you want, and then it just allows you to hang yourself. So it will do things, but that doesn't mean that they're right, okay? Because this is writing to some place in memory, who knows where, but then when the cout catches it, it says it can't do it. Okay, so just something to be aware of. Okay, enough of that. That's their basic data types. So you need those to hold that, but it's like, we haven't interacted with it. We didn't do anything with this. This is just like whatever. But what if instead of assigning the values, now I can assign the values and leave them there, but what if I wanted to make this interactive? What if I said, hey, you know what? I want the user to enter their name. So I can say, please enter your name. And I can say that. And then I'll just prompt. And then what I'll do is I'll read your name in, and I'll store it in name. And that's the way you do it. Notice the cout has arrows pointing to the left. Cn has the arrows. And I could have done this for anything. So now I'm going to say also cout, what is your age? And then I go ahead and output that, and I'll take in the number, and I just store it. Normally the variable should have better names than like A, B. They should be whatever they are. Like if I'm going to store age, and let's do that. So if I was going to do it, let's say that I wanted age, and I don't even have to initialize it. I can just do whatever, right? So then I just say age. Okay. And then what I'm going to do down here after I output all this other stuff that I outputted, what I'm going to do is, I don't want to output all this anymore. I'm just going to comment this. And this is a multi-line comment. Notice /, and then wherever I want it to end, I put asterisk / and that's all commented out. Now this gets ignored by the compiler, so it doesn't do anything. And then this, actually, I should have probably put it up here, because why even assign anything here? So now what I want to do is I want to display the information, and I want to say, hey, I want to say hello, and whatever your name you entered, and let's do that. So I just say cout hello, and then I put the name, and I'll put a new line, put endo. Okay, so now when I run this, I'm going to compile it, and then I'm going to run it, and it's asking me down here, what is, please enter your name, and I say Fernando. And when it says, what is your age? Okay, well, I didn't do anything with age, but let's just say, let's say 30. Hello, Fernando. But it doesn't do anything with age yet, right? I took the input in, and it's there because it read it in, but I'm not doing anything with it. So let's say that I want to do something with the age, and say if age, and I'm going to use a use statement, is less than 20, we output something. We'll say you are young. You are a young whippersnapper. No, because then that would tell my age. So I'll just say you are young. And of course, I have to finish it off. Now you notice that on all the statements that I've been outputting, notice that I've been putting the semicolon at the end. That's very important. C++ needs those semicolons at the end of the lines. But notice I don't have them for things that have bodies, like opening curly braces that have scope. I don't need them. Notice I don't have one at the end of if or at the end of that. But if it's a single line statement, some kind of execution, then it needs the semicolon. But if statement does not need it because it has this. Now, what if I didn't have it? It still wouldn't need it because it doesn't need it. Okay. And that still works. But now this, why do I need the curly braces if the if statement works or if it doesn't work? Well, here's the thing. Here's the reason why. Because, for example, if I do this if statement, it'll execute this line only if, should have been less than 20, if the age is less than 20. But what if I wanted to do more stuff after that? Well, it wouldn't do it unless I put the curly braces around it. And what I mean by that is that okay. So if I didn't have the curly braces, then only the first statement would execute. And this one, even though it's indented and everything, it would not execute. Okay, so another thing, you already noticed that I have an if statement, and this is what an if statement looks like. If statement has the keyword if, it'll have parentheses following it, and it will have a condition after that. Now, after that condition, then it's recommended that you give it a body, and then what is it supposed to do within that if that statement is true? Now, we can say another if statement, if age less than 30, you could say something else. You are young. You are young enough. You're young enough to have fun. Just like that. Just something. Just doesn't matter. And okay, So now what happens though, if if the less than 20 is going to execute this, if the less than 30 is going to execute this, okay? But we have a problem. What do you think is going to happen if they're 14, for example? What's going to execute this? And this statement is also going to execute because they're 14, they're also less than 30, they're less than 20. So both of them will execute. So one thing you would want to do in this particular case is say, well, I don't want this to execute. I want it to execute this or this, but not both. So in that case, you can put an else if statement. That means that if this executes, it will not jump to this one. But if that one doesn't execute, it'll evaluate this one. And if this one's true, it'll execute that one. Otherwise, we can put an else where it'll fall through and just put out a statement and say, hey, you better get ready for your retirement. Pretty young, but some people do retire at 30, right? And so there we go. And so now we have something with age, and we are executing logic, which is what computers are really good at, and doing it really fast. So now we have an if statement, and we have the age. Now keep in mind that we could do this with strings, or we could do it with whatever the logic is. We can make comparisons, and these operators, they can be less than, greater than or equal to. I mean, all the operators that you can use for this particular thing, you can use less than, greater than, not equal, which is like this. So we'll put that one separate. Not equal, basically, that's the explanation for it. You can say equal. You can say if something is equal, and that's the two symbols. And then there will be, you can combine them with and, which is and, or this symbol for or. So for example, I could say if age less than 20, I can say if age greater than 10 and less than 20. So in other words, I'm gonna ignore the 10-year-olds. It's like, you're not even allowed to be here. So they wouldn't even get anything. They'd probably just follow this. But then that would be a flaw, because the 10-year-olds will fall into this logic, and it's like, you could be under 10 or greater than or equal to 30, and you would fall in here. So that could be a logic problem. So you got to consider those things, and those are the kinds of things that you have to consider when you're writing logic. Is your logic correct? Does it do what it's supposed to do? And so that's what you have to consider. So we wouldn't necessarily want to do that, but that's just an example. So let's go ahead and run this here, and let's see, let's execute the program. Okay, I took out too much and I got a compiler error. And so let's go ahead and run it again. Okay, so now we compile it, run it, enter your name. What is my age? And I'll say 21. And it says, you are young enough to have fun, but old enough to get in this, clue. It should have been club. And then of course it says hello Fernando, because this is not inside the if statements, and it goes into all that. So, but if it was a real program, we would probably want to say, hey, maybe this goes before that, right? So you have a lot of logic here, and you may wonder, okay, what can I do with this now? Well, what if, notice every time that we ran this program, we had to run it, it runs and it stops. Well, that's not the way a lot of programs out there work. Think about like the programs that host the internet. They're constantly running. They're just executing, right? So one thing we can do is put this in a loop. And the way you do a loop, there's different types of loops, and I'm going to show you just one. So while, and now this while is kind of like the if statement. It takes a condition. It could take a combination of conditions. Same rules apply as the if statement. I could even just put true, and then it does the body. Now, anything I put inside of that anything I put inside of that while loop will execute over and over endlessly, right? Right. Oh, and it copied everything over, but it didn't tab it in like I wanted it to. So let's go ahead and take this and tab it in once. Okay, so now what this is going to do, this program is just going to continue running and running and running and running, and it's never going to stop unless we kill it. Okay, not something that you necessarily want to do. So we compile the program and then we run it, and I says enter your name, Joe 12. You're not allowed in the club yet. Hello, Joe. Okay, please enter your name. Notice it looped back around. It went back around, and now enter my name, Jane. What is your age? 23. And hello, Jane. You know, okay. And it says the comments, and then enter your name. And it's never going to end, right? It's never going to end. And you notice the logic is executing, you know, like 45, you're getting ready for retirement. But now, like, I don't have a way to end it. So the only way to do it is Control C in this program. But there's a better way to say when it executes. So sometimes programs can say, as a reminder, you know, of course, you'd have to get training and everything and know that, like, hey, what does this mean? You could say -1 to exit. And at this point, I could even say that, you know, if the name they entered is -1, to say if name equals -1, and I just say if it equals -1, I can break, right? Or I can say continue, and then I could say, you know, it's kind of quirky. This is really quirky. A lot of times what you want to do is like in this particular case, I wouldn't want to execute all this extra logic. If they just decided to quit, let me break out of it. Break means that I am breaking out of the loop. That means it goes right to the end of the loop. And what it does, it begins execution here. And then say, for example, here we had goodbye. Say, for example, we have goodbye there. And at that point, it just exits, says, hey, goodbye. Okay. So now if they enter -1, then we can exit out of the loop. We'll save this. Let's run it and run the program. Enter your name, Joe, age 23, and then Jane, and then 45. And then, but now it's like, okay, I'm ready to exit. I enter -1, and you notice it exited and it said goodbye, and it ended the program. So I think I went a lot further than what I promised you. But if you stuck around this long, thank you so much for sticking around and seeing this. And if you have any questions, drop them down below in the comments. Hopefully you learn at least how to create C++. Notice that when I'm compiling it, I have this command called G++, program CPP, and so on. Now, there's different ways to compile your programs. You can look up those commands, but the main thing is that the reason that I can do this G++ command is because I have a compiler installed on my machine. So if you have a compiler, you can do that. And I think I can say G++ version. You notice it tells me the version that I have and all this other information about it. That's the reason that I can compile with G++. So you need a compiler. The editor that I'm using is Visual Studio Code. You can download it. It's free. The compiler is free. So, hey, why not start programming? Now, there was one more thing that I wanted to cover. And if you got something out of this video, go ahead and give it a thumbs up, and you can go ahead. This is the end of that first part, but I would like to show you another part. Like when we look at this code, it's like really long and all this stuff is going on. Remember when I said that it main is a function and we could have different functions? So we can have two types of functions, some that return a value or some that just do something, right, with that information. For example, let's say let's say that I had a function that just says display greeting. And now another thing in C++ is that it is case sensitive. Okay, it is case sensitive, and so the typical way to do these things is to use camel casing. And so the functions start in lowercase, and between words, they capitalize the new word, right? So in this case, display greeting. And what I want to do here is I want to say that I want to have a string with the name. And this simple function, all it does is output the greeting, which, remember what we had for the greeting. Maybe we had all this stuff for the greeting, and say like all of this. Let's take all of this. Oh, too far. We cut all of this and we put it here. And this is gonna need something else though, because it has age. So let's give it the age as well. And notice that I'm adding these things and it's like, where is it coming from? Well, I get to define that information. Oh, actually, this is age, not name. And so I get to define that. And so these are parameters that I can pass to that function. Then that function can use them to do whatever it does. So now when I do this, well, what I can do here is say, instead of doing all that, I can say display greeting. And I just pass it the name and the age, and I can separate my code a little bit. And this type of function does not return anything. And like I said, a function needs the return type. In this case, it says void. That means I don't return anything. And then I have display greeting, and then it returns. And then I pass it arguments and it just does something, right? This is, in some languages, it might even be called like a subroutine, like in Visual Basic, it might be called a subroutine, whereas a function actually should return something. Because if you think of the more mathematical term for function, it should actually return something. Let's say, for example, that I wanted to calculate the volume of a three-dimensional object, right? So let's say that I want to calculate the volume, and let's make it double, right? So let's say get volume, and this thing will need 3 parameters, and it'll be x. Let's give it meaningful names. So let's say width, height, and then length or depth. And I'm making them floats. So I don't know why I did it that way. This should be floats. Let's say depth, right? So and this really, the get volume function, it's not really going to justify its worth because it doesn't do a lot. But in the real world, your functions are going to be a little bit more, they might do a little bit more work, so they're justified. The other thing about functions is that they can hide logic, but like for the volume of a shape, it's not really justified because you could actually do this in line. So you could say width times height times depth. And notice how I did the multiplication there. So your math operators, you can do math, or I could also say like this, if you want to like double, I could say result equals that, but I still have to return something. I have to say return. That means return the result to whoever's calling this function, and then I can return the result. And these are the operators. So it's like multiplication And so there's these operators. There's plus, there's minus, there's multiplication, and there's division. Okay. And with those operators, you can do something. There's also another operator, which is the modulus operator. So we'll put this modulus. And if you remember from like maybe second grade math or something like that, if you divide a number, like say, for example, you divide 10 divided by 2, you know, it's 8. I mean, 10 divided by 2, not 10 divided by 2. What am I thinking? I'm thinking like 10 divided by 8 or something like that, right? So it's like it goes into 8 goes into 10 one time, but you have a remainder of 2, right? So what the modulus gets you is that 2. So if I say 10 modulus 8, then it's going to be 1, but I'm not interested in the 1. I'm interested in the remainder, which is 2. And you're going to see down the road that that comes in very handy. I won't get into it in this session, but just know that it comes in very handy. So those are your operators. And if you want to do more complex math, there's also, you'll find that there's a CMath, or I believe it's a CMath library that has a lot of functions. Like if you're into trigonometry or geometry, and it has like even a value for pi and all those different things, sine, cosine, has a lot more than I probably know because I'm not a big math guy, but there's certainly a lot of stuff that you can use out of there. So now, okay, we display the greeting, but how do we display a volume? And we can just say, for example, that if we wanted to display a volume, we can say double, and I'll just say volume equals, and just to get an idea, and I just pass it like 1.0 or 2.0 by 3.0 by 4.0. And then I can see at this point the volume. Notice how when I do this, I'm actually capturing the result of volume and store it in volume. I don't have to necessarily do that. I can do that right in line. I can say also, I could say it right in line because all the compiler sees at that point is the value that it returns. So I could do it like this, right? So now when I save it and run it, I mean, I have to compile it first, of course. And oops, let's see, compile it. There we go. Run it. Please enter your name, Joe 12. Okay, hello, Joe. Please enter your name. Okay, but you notice it did the volume here twice. But one thing that I didn't do for the volume is this, I should have probably put volume here and there and a new line. It's always good to use it. Well, it depends, right? But most of the time you do need a new line. And I don't know why I always add an in there. And then of course the new line, so you can see it more clearly. So let's go ahead and give it a try again because they did it together in this example. Oops, let's go -1, let's exit. Compile it, run it, and let's say that, okay, I'm done entering name. Well, no, actually I gotta enter at least one Joe, age 122. And so do you notice that it did the volume 24 in volume 24, and that's from this one where it actually captured the result. And this one didn't really store the result. It just kind of inlined it and it just displayed it on there. So those are the two things. So with this, armed with this, you can actually do a lot. But there's a lot more to C++. If you want to keep watching these videos, please subscribe and I will post them. And if you're really interested in watching more, go ahead and click that alert button so you get alerted. And if you like this video, please give it a thumbs up. Help me improve my stats, and that way the YouTube algorithm will bring other viewers like you here. Thanks for watching.